Let's take a look at combinational logic gate AND. If you are a computer engineer or working in the field of computer science, you must be already familiar with the AND gate. AND gate, we also know it as a truth table. Suppose we have a statement or we have a person and we are asking two questions from this person. We want to check if this person is trustworthy and we can trust him or her or not. In this example, the answer to the first question is false. So when it's totally false, we will give it a 0. When it's totally true, then we will give it a value of 1. The answer to both questions here are false, so we gave both of them 0 and the output would be false as well. We cannot trust this person, so it's 0. The answer to first question is 0, it's false. The answer to second question is true, and we are just showing it with a value of 1. But still we cannot trust this person because he or she just told us one false statement and one false answer. So the output would be again 0 and we can't trust this person. Here is just the reverse. The first answer is true, the second answer is false, meaning we cannot trust this person again. But if the answer to both questions are true and we have two truth statements, then we show both of them with 1 and we can already trust this person and we can show it with a value of 1. However, if you work with a fuzzy logic, you may realize that it's not only totally true or totally false, and sometimes we have an answer which is something between these two, some degree of, we have some, in a fuzzy logic we have some degree of truth. For example, this Alex is rich. We can give it a degree of truth of 0.2, meaning this is not totally true, not totally false, but here is something in between. Fuzzy logic emerged in a context of theory of fuzzy sets, which was introduced by Zadeh, Iranian scientist and mathematician, in 1965. In a fuzzy logic, we just discussed them more and we will give to our system some statement and some degree of truth. Okay, let me just erase it and back to our discussion here. Here we have y and this one is our x. Whenever the input is 0, 0, I will show it here. This is a point 0, 0, and another one is 1 and 0. When x is 1, y is 0, somewhere around here. Another one is whenever y is 1, x is 0. Here, for these 3 zeros, we are showing it with a blue circle. Another output that we have here is whenever the inputs are both 1. So let's show it with a triangle. If this is 1 and here we have 1, then 1 and 1 is somewhere around here and we are going to show it with a. We have two sets of data. We have 0 and we have 1. We are looking for a line to separate these two sets of data. We can already draw infinity number of lines to separate these two sets. But we are looking for the best line to have a minimum error. For this purpose, we can use another method which is called supervector machine. Supervector machines are actually giving you the best fitting line here with a minimum error. We will discuss it more when we are talking about mean square error, but for now let's just erase them. We are actually doing the classification here. I'm gonna choose 2 points here and let's say this is a half, 0.5, and this one is also a 0.5. So we can write a function for this line by showing x plus y is equal to 1.5. The output, which is z, we can have a function for z already. Z can get actually two values. It can be 0 or it can be 1. When x plus y is less than 1.5, here it's just covering this part, meaning the output is 0 and it's false. Whenever we have the 1 for output, we have x plus y greater than 1.5. It just shows all the outputs of 1, which in this case we have only one triangle. We need to put an equal for one of them. In this example, it really doesn't matter where are we going to put the equal sign, but based on your data, it's your call and it's your decision to complete your function. I'm just showing it here. So here we have already a function for truth table or for an AND gate.